Week 8, Set 2, SWYK 1. Alright, a lot of stuff here to go through. Hopefully that we'll get this done in 7 minutes. Always looking for that GCF to see if there's a GCF. Answer in this case, nope. Alright, so we need them to multiply together to give us 144, positive 144, and they have to add to negative 24. Well, the only way they're going to add a negative 24 and multiply to a positive number is if they're both minuses. The things that multiply together to give us 144, this would, obviously there's like 144 and 1, but, they don't add up to negative 24, even if you make them both negative. The one we're looking for is 12 and 12, okay? So, we got a 12 here and a 12 here. Do you notice that both of those are the same? P minus 12 and P minus 12. This means we're dealing with, this thing right here is, hold on a second, this thing right here is called a perfect square trinomial. Perfect square trinomial. Now, why do they call it a perfect square trinomial? Because it is a perfect square. Now, it's trinomial because it's got 3 terms in it. But you can write it as a perfect square. That's something that's very useful when we come to solving equations, which will be in our next SWYK. All right, moving on. So, next one. No GCF. This time we got to take the square root of 49x squared. We do that, we get 7x. We got to multiply together to give us 1. Not a whole lot of options, folks. So, got to add 1, right? Outsides and insides would then add up to 14x. All right, so that is, oh, wow, yeah, it's another one of those perfect squares, isn't it? Perfect square trinomial. So we got 7x plus 1 quantity squared. You want to say it like that, quantity squared, especially at a party. People will make fun of you otherwise. Now, the next one here is going to look like a magic trick. In fact, it looks like 2 magic tricks. So you got to pay attention and watch. We're going to maybe not practice it a lot right here, but you're going to practice it more and more as we continue, not only with this SWYK, but the next one as well. Okay, so when I was in school, they never taught me this little trick. They just said, hey, if you want to figure out what multiplies together to give you 6x squared, then you're going to have to test out 6x and 1x, or 3x and 2x. Now, that's fantastic, but what if we get to 8x squared? Then that's got 8x and 1x, 4x and 2x. What if we get to 12x squared? Then we got 12x and 1x, 6x and 2x, 4x and 3x. Okay, it's getting ridiculous, the number of possibilities that you have to keep trying. So, it would be nice if there was one method that would work all the time, and there is. So, I want to show you how to do this, and I'll leave it in purple. So the first part of the magic trick looks like this. I'm going to take this 6 at the beginning, and I'm going to multiply it times the 3 at the end. It's almost like I pick it up and drop it on the 3 at the end, okay? And when I do that, it looks like this right here. Maybe I should, yeah. X squared plus 11x plus 18, right? The 6 just kind of magically got multiplied times the 18, okay? The reality of this whole process is kind of really cool if you actually do the graphing of it, because you actually have 3 different parabolas and they share some common x-intercepts. But, that's beside the point. At least the first one and the last one do. So, let's take this and factor it like we normally would. They have to multiply together to give us 18. They have to add up to 11. So, of course, we got x plus 9 and x plus 2, right? So that would be the normal way to factor it like you normally would. Okay, so here's the second part of the magic trick. Notice in the blue, the 6 that magically disappeared reappears in front of both of the x's. Okay, now, this is the part that helps us finish off this question. I need to get this out of the way. My face is in the way. Look at the parenthesis and ask yourself this question. Is there a greatest common factor that needs to be pulled out and eliminated? Yes, there is. They both have a 3. So I can pull a 3 out, and that gives me 2x plus 3. So go to the next one. Oh, by the way, there's not always something you can pull out. Sometimes they just That's as far as they go. But 6x plus 2 has a 2 in it, right? So I can take that out, 3x plus 1. So this one was the one we should have chosen. And we end up with this as our final answer. If you don't believe me, FOIL it back together and see what you get. Your outsides and insides would add up to 11x. Your last would be positive 3. Your first would be 6x squared. It works. It's a double magic trick. Now, we could go through the proof of it. The proof is nasty. I saw it online. It is ugly gross. Graphing at least makes more sense and looks nicer, but trust me on this one. Practice this. Multiply the first times the last. Factor it like normal. Plug the coefficient back in front of both x's. Look for GCFs and get rid of them. Works every time. Very nice and smooth. Okay, next. We're dealing with... Oh, is there a GCF? Yes! Finally, we've got a GCF, right? We've been, blasting that question all over the place. Pull out a 7. That's the first thing you want to do. That leaves you with x squared minus x minus 30. Now, the remaining part can be factored. Notice how it said factor it completely? What they're trying to tell you is go all the way. So even though we pulled out a GCF, that's not the only thing you can do here. So factors of 30 that have a difference that add up to -1. So we want a -6 and a +5 because they multiply together to give me -30. But when you do the outsides and the insides, you get -1x. So there's your final answer on question 4. When you get down to question 5, does it have a GCF? Yes. It's a 5. You pull it out. Well, that's a difference of perfect squares, remember? So they, take the square root. You got r and r. And then, of course, they need to multiply it to a negative number. In this case, -64. So 1's plus, 1's minus. And they have to add up to 0 because there's no middle term. Of course, it's 8 and 8. Right. There's your final. Question 6. Do we have a greatest common factor? Now, one of the things I want to say about that double magic trick thing, you cannot have a greatest common factor left inside in order to use that trick. You must pull out the common factor first. So that's why I wanted you to see this question. You pull out the common factor first, and then what's left can be used with the double magic trick. So we take the 5 and we multiply it times the -3. That gives us this one right here. And then we factor it normally, right? We got a -15 and a +1. And then we put the 5 back in front of both of the x's. And then we look for GCFs. This one doesn't have a GCF, so it stays the same. This one over here, 5x minus 15 has a 5. You can pull out the 5, and that gives you the x minus 3. Awesome. And now we're done with that question. And there's that 7's a duplicate. You can look through that one. 8. This question right here is using your skills. Remember, area is length times width. We're talking about a rectangular field. They tell us the width is x minus 60. They do not tell us what the length is, but they do tell us that the area is x squared minus 150x plus 5400. This question's easier than all the other ones. Why? Because they gave me one of the factors. So the truth of the matter is, if you can figure out -60 times negative what gives me positive 5400. So all I need to do is take the 5400 divided by -60, and you'll know that it's -90, right? So that means the factor, the length would be x minus 90. So it's actually an easier question than other things. Just because it's a story problem that has words, don't be frightened. Okay, see you in the next SWYK.